Hello everyone, this is problem 62 of Neetcode 150. Last stone weight. Alright, so in this problem we're given an array of integer stones where every values at a specific index represents the weight of the stone at that index. We want to run a simulation basically where we are going to take at every single step the two heaviest stones in the array and we want to smash them together. So if both stones have the same weight, both stones will be destroyed, and there won't be an additional stone or a resulting stone added to the um, the array. All right, and if there is one stone that is heavier than the other one, well, let's say that you have a stone that has a weight of 5 kg and a stone that has a weight of 3 kg. Well, by smashing them together, the 5 kg uh, is gonna become a stone of 2 kg because that 3 kg rock will have destroyed another 3 kg of that 5 kg stone. So this is the logic of the problem. And at the end, we either have an empty array or we have an array with a weight, right? So there is only one weight. That's a possibility. So we have to return 0 or that weight. So to solve this problem, there is the sorting approach, which is possible. It is not the most efficient solution because every single time that you add a resulting rock after smashing two rocks together, you are gonna have to resort it, which is feasible but not the most efficient solution. In our case, what we are going to be willing to do is to have a max heap. So a max heap, similarly to a min heap, is a complete binary tree where the top value is always the greatest value. Okay, so if we keep a max heap, we can simply take the first value of that max heap and then take that, and once we took out the maximum value, we can take again the maximum value of that resulting max heap so that we get the two heaviest stone in the array. All right. So unfortunately in Python there is no such thing as a max heap, but there is a min heap. So let's say we have let's say we are given an initial array with 1, 2, 3, and 4. All right. Well, we are gonna have we want to have a max heap where the maximum value is at the top, so it's 4. Then you're gonna have 3, then 2, then finally 1. Okay, but since this is not possible, we can only have min heap. What we're gonna do is that we're gonna simulate that, and we're just gonna add a negative value for each. So we're gonna multiply them by -1. Okay, so you see that our maximum value 4, when it is multiplied by -1, it becomes the smallest value. Okay, so by doing this, we can now pop out our -4. And by doing this, the min heap or the epify function in Python is gonna automatically just rebuild the tree with the minimum value at the top. So this is super convenient. And now we're gonna pop out again that top value here. Boom. So we are gonna take the difference of these two. And you know that technically this rock has a weight of 4 kg if we use the units kg, and this one has a weight of 3 units. All right, so the difference after smashing them is 1, right? So after you smash both, you are going to be you're going to receive basically a difference of 1, but recall that every single value that we add in our min heap has a value of a negative value of itself. Okay, so we are gonna add back in our min eep this value here, and now we're gonna pop out again the two minimum values. All right. So by looking at this, we have -2 and -1. So this tells us that we have a rug of two units of weight and a rug with units of weight of 1. So the difference after we smash both, according to the logic of the problem, is going to be 1, but we have to actually use a -1, right? So we're going to add -1 to our, our min e. This no longer exists. And after we take the two smallest value of our min e and we smash them together, so we have both rocks are basically has a weight of 1 units. So smashing both together will result in 0. Okay. All right. So so that's great. So now we can actually go code the solution because we understand the logic. So we know that first I'm gonna have to recreate stones, okay? Because stones right now is has only positive values. So let's just create a stones where all the positive values are gonna be the inverse of themselves. So -4, so 4 will become -4, 5 will become -5. So we can do this by saying that stone is going to be equal to the negative values of stone for all the stone in stone. All right, so it's going to take every single values and going to re-render its negative version of it. And after this is when we want to create our min eep, since there is no max eep in Python. And we can do this quite easily in Python. We can simply call eep q.heapify. It's going to take a time complexity of big O of n, which is really not so bad. And we're going to pass our stone in it. So this is how we actually create a min eep. Quite simple. It is exactly 3 words, 2 brackets, 1 dot. So when I first started learning about min eep, I thought that the logic will be quite complex because we have to handle like the extraction of the minimum value at every time we pop a value out of this tree, and we also have to rebuild it. But actually Python has this heapify function that does it for us, so it is super convenient. All right. In the example that I showed you, we end up having 2 rocks of 1 units of weight, and smashing them resulted in an empty array. But it is possible that we are gonna have a rest, like a leftover in the array. So if we have a leftover in the array, we are gonna have to return this. All right, meaning that we are gonna base our logic on the array. So we're gonna have to base this logic until the array of stones is greater than 1, because it might be 0 or it might be 1, but if it is greater, we have to keep going into a logic. So if the length of the stone is greater than 1, this is where we are gonna have to do our things to make the problem work. So first we have to call the let's say the heaviest, and the heaviest is going to be the first value that we're going to pop out of the min eep, and we are going to use a built-in function in Python with that's going to use a time complexity of log n, and this is in the same library. So eepq.eep_pop, right? And we want to pop from the min eep stone. All right, and now we have our, let's say let's call this second heaviest. All right, and this is, we're gonna pop again from the stones min eep, so eep pop. All right, so now we have the heaviest and the second heaviest rock in the array. Um, but recall that both rocks are of negative values. Okay, so the heaviest might have a weight of like 5 kg, and the second heaviest it has a weight of 4 kg. But what we're going to retrieve is that the heaviest is going to be actually -5, right? And the second heaviest is going to be -4. So this tells us that in our logic, if we render heaviest minus second heaviest, we are going to have -5 minus 4. So it's going to end up giving us -1, which is the negative version of the absolute difference between the rock that is actually 5 kg and the second rock that is 4 kg. And this is good for us because we want to render that negative difference inside the min heap. So actually, since we are using a min heap, we know that the heaviest rock is going to be either smaller or equal to the second heaviest rock. So what you really care about before we smash two rocks is just to know if both are not equals. We know that if both are not equals, it means that the heaviest is smaller than the second heaviest. And if they are equal, we are just going to pop them as we did here. And we're not going to do anything else because both rocks are going to be smashed and are no longer going to exist. So we can simply say that if heaviest is not equal to the second heaviest, all right, so this is where we are going to use the heap push function. And the heap push function is built in Python and is going to assure us that the value that we add is going to go at the right place in the min heap. So if it is the smallest value, it will go at the top. Otherwise, it will take the right place. So we don't have to handle all the logic of rebuilding the tree according to what a correct min heap is. We can simply say heap q. So we call this library. Then heap push. And inside heap push, we have to say which min heap we are referring to. And we want to push in. So here it is stones. And we have to say what is the value we want to actually push in, and here it is the negative difference, so it will simply be heaviest minus second heaviest. Okay, so that's actually it. We are going to continue this while loop until we either have a stones array of length 1 or a stone array of length 0. There is one edge case though. It's what if we have a length array of 0. In a problem, we are supposed to return 0 if this case is true. So what I will do is that I will simply append a 0 to that stones array, so that if there is already a number, it's going to go at the index number 1. Otherwise, it will take the index number 0. So it is safe for us to do this because what we are going to return is the absolute value of the first, or the index 0, just like this. So it's going to take the first number and it's going to turn that first number in its absolute value, so that we are getting back our actual stone weights. So that's the entire logic. Now I can run the algorithm and see that it works just fine. So there we go. Alright, so I hope you learned from this video, and I hope to see you in the next one.